Right, so we've looked at all the different differentiation techniques, right? And so now we can look at the second derivative. So in the first pure book, pure 1, we looked at the second derivative because it told us when a stationary point was whether a maximum point or a minimum point. However, it tells us a bit more now because we can actually say whether it's a concave or a convex curve. So when it's less than 0, we say it's a concave curve, and when it's bigger than 0, we say it's a convex curve. So concave just means the shape which looks kind of like a U, and convex means it's like so concave is upside down U, convex is just a U shape, and so it allows us to sketch more difficult graphs. When it's equal to 0, it's actually called a point of inflection, and this is when it changes from a concave to a convex shape. Okay, it inflects from a concave to a convex shape, or vice versa, the opposite way around, a convex to a concave shape. So when the second derivative is equal to 0, then we know it's going to be a point of inflection. And so with this, as I said, we can draw more difficult graphs. Let's take a look at this question here. So we have a curve C, which has equation y is e to the x times x squared minus 2x plus 2. And it says find the exact nature of the exact coordinate of the stationary point and determine its nature. So we know that the stationary point is when the derivative dy by dx is equal to 0. So what we need to do now is just differentiate this first. So we can use the product rule because we have two functions. So we have e to the x, x squared minus 2x plus 2, plus e to the x, 2x minus 2, which we can simplify a bit further. So we get e to the x and then just x squared here because the 2x's and the 2's cancel out, right? And so we equate this to equal to 0 and we try and find the x position. Right, so e to the x can never be equal to 0, meaning that x squared has to be equal to 0, therefore x is going to be equal to 0. So that's the x coordinate. Finding the y one, we just plug it back into this here. So I have e to the 0, and then 0 squared minus 2 times 0 plus 2, which will give us just 2, so the stationary point will be 0, 2. Right, they've asked us now to determine its nature. Nature just means is it a maximum point, or is it a minimum point, or is it a point of inflection? So the way we work that out is we differentiate it again, right? So d2y by dx2. So we get e to the x, x squared plus 2x e to the x, which is e to the x, x squared plus 2x. And we just plug in our x value, which is 0, into here. So we get e to the 0, 0 squared plus 2 times 0, which is actually equal to 0. Right, so if it's equal to 0, it means that it's neither a maximum point or a minimum point. In fact, it's a point of inflection, like so. Okay. Right, part B. Find the coordinates of any non-stationary points of inflection. So we found a stationary point, which was a point of inflection, but they're saying there's actually more point of inflection points. So we would just say the second derivative is just equal to 0. And we worked it out before, right? So it means that e to the x, x squared plus 2x is equal to 0. Once again, e to the x cannot be equal to 0, so therefore x squared plus 2x has to be equal to 0. We can factorize this to give us this, so x is going to be equal to 0 or minus 2. So there are 2 points which are actually points of inflection, 0 and minus 2. The first point, 0, is the one we found earlier, and the second point, minus 2, is the second point of inflection. And they want the coordinates, so I just need to plug this back into the y equation to get my coordinates of the point of inflection. Right, let's take a look at this question here. So we have a curve which has equation y is x times e to the x. In part A, they're asking us to find the exact coordinates of the stationary point on C and determine its nature. So once again, stationary point means the first derivative dy by dx is equal to 0. So I just need to differentiate the curve or the equation y is x e to the x. Using the product rule, I get x e to the x plus e to the x, and we equate this equal to 0 to find the stationary point, right? I get the e to the x out, x plus 1 is 0, so x is going to be negative 1. This is going to be the stationary point. It says the coordinates, so I need to find the y coordinate. I can plug it back in, so y is equal to minus 1 e to the minus 1, which is minus 1 over e. So the coordinate of the stationary point is going to be minus 1 comma minus 1 over e. Now they're asking us to determine the nature once again, meaning is it a maximum point or a minimum point or a point of inflection? And in order to know that, we have to differentiate again, right? So d2y by dx2 is equal to e to the x, differentiating this one again, right? Using the product rule, x plus 1 plus e to the x. I can simplify this a bit, so it's e to the x, x plus 2. And I have to plug in now my x coordinate, which is minus 1, into here. So I get e to the minus 1 plus 2, which is equal to e to the minus 1. This is bigger than 0, right? So if it's bigger than 0, then we know that it is a minimum point. Right. B, find the coordinates of any non-stationary points of inflection. So once again, we just have to equate the second derivative equal to 0 and find any x values when it's equal to 0. So e to the x plus 2 is equal to 0. So x is going to be negative 2. So this point here is going to be a point of inflection. If I was to find the y value, I just plug it back into the y equation. So y is x e to the x, right? So it's going to be minus 2 e to the minus 2, which will give me minus 2 over e squared. So this here is going to be a point of inflection. And C is finally asking us, hence sketch the graph of y is equal to x e to the x. So as I said, we can now sketch these kinds of graphs because we've found a lot of different points and we know where the maximum are, the minimum are, or the point of inflections. So y is x e to the x. Okay, things we do know is we know that, well, in part B, the coordinate minus 1 comma minus 1 over e is a minimum point. So we know that's a minimum point. So that's one point we can draw straight away. So minus 1 over e, this is going to be a minimum point. We also know that minus 2 comma minus 2 over e to the squared is going to be a point of inflection, meaning that it's going to turn from a convex to a concave or a concave to a convex one, right? So it's just a matter of knowing which one is it going to turn into. Well, we've worked out that, well, at this point here, it's a minimum, right? So minus 2 comma minus 2 over e squared is going to be roughly here. And so therefore we know that it's going to move, because up here, it's going to move slightly to this way here. And then we also know it's going to pass this 0, 0, because if I just put in x is 0 into here, I get y is 0. So the curve will look slowly something like this. It's just a matter of changing or just plotting the graphs, okay? So as you can see, it's going from a convex portion here, and at this point of inflection, it's changing into a concave graph like this. So that's what the point of inflection tells us. It's going from convex to concave. And that's really about it. You just need to know second derivative is equal to 0, it will be the point of inflection. You need to know if it's a concave or convex shape, and you need to find out stationary points and whether it's a maximum or minimum. And with this, you can just about draw any different type of graphs that they could give you.